Hi, this is Akshay and with another video based upon the types of chemical reaction. In the previous videos, we have understood combination reaction as well as decomposition reaction. Now it's time to take on another type that is called redox reaction. As I told you before, that is redox. The word redox is made up of, you can see, two subwords here. One is red, red means it is reduction, and another one is ox, and ox is coming from the word that is oxidation. So here it's quite clear that is a chemical reaction in which reduction as well as oxidation go on simultaneously is called redox reaction. So that's the definition for redox reaction. Now reduction and oxidation have got a different kind of definitions there, just opposite to one another. Three definitions are there which are meant for reduction and same meant for oxidation over here. So it is quite clearly illustrated over this very green board here, that is yes, but reduction and oxidation is gonna be. Here it is. It is oxidation and it is reduction. Loss of electrons is called oxidation. You can see this very big arrow indicating that electrons are being lost, and this head is pointing in this very direction. It means it's being lost over here. Here it's being gained. So the loss of electron is called oxidation, whereas gain of electron is called reduction. This is called electronic concept. We will take the examples of these three definitions by means of a chemical reaction. But let me tell you, as far as this electronic concept is concerned, that is gain of electrons and loss of electrons, that is called electronic concept of reduction and oxidation. This very electronic concept we will try to understand when we are gonna take on the another type of chemical reaction, that is displacement reaction. And in displacement reaction we will try to understand the mechanism involved in that kind of a displacement reaction. Let me tell you, over there you will see the glimpses of electronic concept involved in redox reaction there. So this is what being reserved for the coming videos over there. So first, today we are gonna take on these two, you can say, definition in the form of chemical reactions there. So there you are right now. That is the first definition for reduction as well as oxidation. Loss of electron is called oxidation, whereas gain of electron is called reduction. That's the one definition. This is called electronic concept. Now, number two definition is that loss of hydrogen or any electropositive element. Loss of hydrogen means any substance or any species which is losing hydrogen is undergoing a process called oxidation. If it is the straightforward loss of hydrogen or any electropositive element. What is electropositive element? Electropositive element is that kind of element which loses its electron in order to acquire the stable electronic configuration of nearest noble gas, thereby becoming a positively charged particle or a positively charged ion. That is called electropositive element. For example, you can see sodium. Sodium is an electropositive element. You know, it has got one electron in its outermost shell. That's its electronic configuration 2,8, 1, and it will lose one electron in order to acquire the stable electronic configuration of nearest noble gas, that is neon, having atomic number 10 and its electronic configuration 2,8, and it is sodium and plus 1 here, because with the loss of one electron positive charge will appear. Remember, positive sign on a given charge is an indicator that it is deficient in electrons. Here it is plus 1 or plus, it means it is deficient in one electron, and there you are, this is one electron. So sodium, here it is, sodium is an electropositive element because by losing one electron it got transformed into positively charged ion, that is called electropositive element. So number two definition says that oxidation means loss of hydrogen, any species which is losing hydrogen or any electropositive element. So it means you must know that is whether the element being lost by a substance is electropositive or not. So I have told you that is electropositive elements are those which tend to lose electrons, thereby acquiring the stable electronic configuration of nearest noble gas, and in the process got converted into positively charged ion. Remember, metals are having electropositive character, so there you are right now. Loss of hydrogen or any electropositive element is called oxidation. You know, here another arrow is coming up here towards this one, means it's the loss over there, gain is here. So loss of hydrogen or electropositive element is called oxidation, opposite in the case of reduction. Very simple to just memorize these definitions, provided you know what's the pattern running through these definitions. Here it's loss, one's loss, others gain. Yes, gain of hydrogen. There is loss of hydrogen, here gain of hydrogen, or once again, or any electropositive element I have mentioned, but is the electropositive element. So any species which is gaining hydrogen, or for that matter any electropositive element, is undergoing the process called reduction. That's the definition number 2. Okay, and this very definition number 2 in the form of chemical reaction is being mentioned over here. I am coming over to this very chemical, you can say, reaction there, just to understand the second definition of reduction as well as oxidation. Last and final, that is, yes, gain of oxygen or any electronegative element. Yes, electronegative element, as the name is suggesting, electronegative element. What are electronegative elements? Those elements which have got tendency to gain the electron in order to acquire the stable electronic configuration of nearest noble gas, thereby got converted into negatively charged ion. Those elements are known as electronegative elements. Remember, non-metals are electronegative in nature, because non-metals have got tendency to gain the electrons in order to acquire the stable electronic configuration of nearest noble gas, and in the process non-metals got converted into negatively charged ions. Let us take an example of chlorine. You know, atomic number is 17. Here it is chlorine, and its atomic number is 17, 2, 8, 7. You know, it is having 7 electrons in its outermost shell. It means chlorine is in need of 1 electron in order to acquire the stable electronic configuration of nearest noble gas, that is argon. So 1 electron is being gained here, and what's gonna happen? Yes, 1 electron being gained, Cl, that is chlorine, will gonna transform into chloride ion, Cl minus 1. Minus 1 is an indicator that it is having 1 electron more than its own capacity. Why minus 1? Minus means electron in excess. And how many unit minus is there is an indicator that the number of electrons are in excess over there. So it is minus 1. It means it has got 1 more electron than it is, you can say, than it has got a capacity, or but its capacity, 1 more electron, minus 1. It is called chloride ion, and you can see its electronic configuration turned out to be 2, 8, 8, and it's collectively 18, and 18 is atomic number of argon. So Cl minus 1. Here this chlorine is electronegative element, because by gaining 1 electron it got converted into negatively charged ion, and that's why the word is electronegative. Gain of electron, releasing the negatively charged ion or giving the negatively charged ion, that's why that element is going to be known as electronegative element. So then, yes, oxidation means gain of oxygen, as the name, oxidation, gain of oxygen or any electronegative element. Non-metals are electronegative in nature, as you know, oxygen is also non-metal. So gain of oxygen or any electronegative element is called oxidation. But here the loss of oxygen, just opposite, and you can see the direction of arrow is indicating in this very direction. That shows here it is the loss, there is the gain. Loss of oxygen or any electronegative element is also known as reduction. So this is another definition for reduction. Loss of oxygen, here gain of oxygen. Loss of oxygen or any electronegative element is called reduction, and here gain of oxygen or any electronegative element is called oxidation. So these three, you can say, definitions meant for reduction and oxidation must stay in your mind. So you can note them in your notebook there by having just a clear-cut idea what the reduction and the oxidation are gonna be. So once you know the definition of both reduction and oxidation, yes, 50% battle is over. Now time has come to just use those definitions in order to identify that, yes, how that reduction and oxidation going on in a given redox reaction. So let us take an example of for this very number 2 definition, and this number 1 definition, that is the electronic concept of reduction and oxidation, we will discuss in the displacement reaction there. Okay, here it is, gain of hydrogen or any electropositive element. I am just wiping it away just to focus on the chemical reaction I have already written here. And remember, this chemical reaction is showing the glimpses of the second definition of oxidation and reduction, which involves the gain of hydrogen or loss of hydrogen. There you are right now. Here it is. So that's the already I have got this one. Yes, there you are right now. Hydrogen sulfide gas and here it is chlorine gas, both are reacting together to give you hydrogen chloride and sulfur. So let us see here, the best way is to just juxtapose reactant products over there. Just juxtapose and see what's happening over there. Here it is hydrogen and sulfur making hydrogen sulfide. Just see over there what's happening to hydrogen sulfide here. Just you can notice here it is hydrogen and sulfur together, and over here you are noticing there is only sulfur. What does it mean? That is, during this very chemical reaction or a chemical change, hydrogen sulfide has lost hydrogen, thereby leaving behind only sulfur. Here it is, hydrogen sulfide, here it goes, and the journey begins from hydrogen sulfide. Go where it's gonna end up. See here, it is over here sulfur. That is a clear-cut indicator of the fact that hydrogen sulfide is losing hydrogen and thereby got converted into sulfur, because here no hydrogen is left. So then, loss of hydrogen we have learned in the definition number 2. The loss of hydrogen is called oxidation. One's loss, another one's gain. And remember, both go hand in hand, both go simultaneously. So one has to lose so that other can gain. That's how this reaction is going to proceed. So it has lost hydrogen, and hence we will say hydrogen sulfide got oxidized into sulfur by losing hydrogen. Now come to the another case here, chlorine. Here is only chlorine. But in the product side, see over there what is happening. Chlorine is in the company of hydrogen. It means during this very chemical reaction, chlorine has gained hydrogen. So hydrogen here being lost, chlorine has gained it. So gain of hydrogen is called reduction. Thereby chlorine got reduced into hydrogen chloride, and that's known as the reduction. So remember, both are meant for one another. They are doing a job for one another. And what kind of a job? One is losing so that other can gain. So that other can gain. So one's loss, another's gain. Now this is quite clear here that hydrogen sulfide is undergoing the process called oxidation. Whereas chlorine, by gaining the hydrogen, got converted into hydrogen chloride. It means the gain of hydrogen is called reduction. Since during this very chemical reaction, both oxidation as well as the reduction go on hand in hand, go on simultaneously, and hence this chemical reaction is known as the redox reaction. Second definition is befitting over here. That's one thing. The another thing we are gonna see here, no action will take place without any kind of agent. You need to have agent. If there is oxidation going on, it means there is an agent. If there is reduction going on, it means there is an agent. So an agent which carries out the process of oxidation is called oxidizing agent, and an agent which carries out the process of reduction is called reducing agent. So let us see which one is the reducing agent. You can see here that is hydrogen sulfide. Hydrogen sulfide, by supplying hydrogen to chlorine, to reduce it into hydrogen chloride. It means it is hydrogen sulfide which is carrying out the reduction of chlorine, and that's why hydrogen sulfide is known as reducing agent. This is reducing agent because it is carrying out the reduction. Whose reduction it is carrying out? That is chlorine. The reduction of chlorine can't go on its own. Nothing can happen without any external action. Here, chlorine can't just reduce into hydrogen chloride unless until it is being just supplied with hydrogen for that kind of a reduction to take place here. And where that hydrogen is coming from? It is coming from hydrogen sulfide. It means hydrogen sulfide is releasing hydrogen so that it can reduce chlorine into hydrogen chloride there. Since hydrogen sulfide is carrying out the reduction of chlorine into hydrogen chloride, and hence hydrogen sulfide is called reducing agent. What is happening to chlorine? Is it playing a role of any agent? Of course, yes, it is also, because here it's not the only one kind of action going on. Two kinds of actions are running hand in hand. If there is a reduction, oh yeah, there is also oxidation going on. It means what's happening? Hydrogen sulfide is made to lose hydrogen. Now question is arising here. Who is making hydrogen sulfide to lose hydrogen? It is none other than chlorine. There is a force behind it, and that is the chlorine which is making the hydrogen sulfide to lose hydrogen. It means hydrogen sulfide, by losing hydrogen, undergoing the process of oxidation. And a question arises, a fundamental question arises. Oxidation is a kind of action which is being carried out by an agent. And where that agent is located? Yes, it is chlorine. Chlorine is playing that very role here. Chlorine making the hydrogen sulfide to lose hydrogen. So since chlorine is clicking the loss of hydrogen from hydrogen sulfide, and hence we know loss of hydrogen is called oxidation. It means chlorine is carrying out the oxidation of hydrogen sulfide into hydrogen sulfide into sulfur. Here it is, hydrogen sulfide into sulfur, and hence chlorine is known as oxidizing agent. Chlorine is here oxidizing agent. So that's called oxidizing agent. One is reducing, another one is oxidizing, and that's the you can say second definition, which is being illustrated by means of the chemical reaction here. Now another third and final, you can say, that is definition we will just illustrate by taking another chemical reaction here, and it is cupric oxide reacting with, yes, cupric oxide reacting with it is cupric oxide reacting with hydrogen to give copper plus water. Here it is. Or see then, which is undergoing the process of reduction and which is undergoing the process of oxidation. Firstly, pick up this one, cupric oxide. You are going to take cupric oxide, copper is there. Just locate copper over there and see what has happened during this very chemical reaction. So here it is. You can see here cupric oxide has got converted into copper. That's how you are gonna juxtapose reactant and product, so that you can make an idea or make a sense that is what has happened in reality over there. Here it is copper along with oxygen called cupric oxide, but here only copper is left during this very chemical reaction. It means this is known as the loss of oxygen, and loss of oxygen is called reduction. This is called reduction. Here it is. It means cupric oxide is undergoing the process of reduction to give you copper. But what is happening to hydrogen? Here it goes. Hydrogen, and you are going to end up over here. It is. Hydrogen got converted into water. What are you noticing here? A change is being there. Here it is only hydrogen. But here hydrogen is in the company of oxygen to give you water. It means during this very chemical reaction, what the hydrogen has done, that it has gained the oxygen. Here you are, gain of oxygen, and gain of oxygen is known as oxidation. That is called oxidation. It means hydrogen got oxidized into water. So we clearly mentioned here reduction and oxidation going on simultaneously, and hence this is also an example of redox reaction. Remember, this kind of a chemical reaction illustrating the third definition of the oxidation and reduction, which says that the gain of oxygen or any electronegative element is known as the oxidation, and the loss of oxygen or any electronegative element is called reduction. So here it is, cupric oxide is reducing into copper, and the hydrogen at the same time, by gaining that very oxygen which is being lost by cupric oxide, got converted into water. Now the time has come to find out the reducing agent and oxidizing agent. As I have told you, whatever the actions is running across this very chemical reaction, it is being controlled or it is being carried out by an agent. And it means oxidation is going on, it means there is oxidizing agent. Reduction is going on, it means there is reducing agent. So let us figure out here which is oxidizing agent and which is reducing agent. Since cupric oxide and here hydrogen, here cupric oxide is losing oxygen so that hydrogen can gain that very oxygen to get converted into water. So hydrogen is gaining oxygen to get converted into water. It means oxidation of hydrogen is going. So who is just carrying out the oxidation of hydrogen? It would be carried out by that kind of a species which is supplying oxygen to hydrogen. Who is supplying oxygen to hydrogen? It is the cupric oxide which is supplying oxygen to hydrogen to get oxidized hydrogen into water. It means cupric oxide is carrying out the oxidation of hydrogen, and that's why cupric oxide is called oxidizing agent, because it is carrying out the oxidation of hydrogen by losing the oxygen so that hydrogen can gain it to get converted into or get oxidized into water. And the next half you will see that yes, but the hydrogen is doing. Hydrogen is making the cupric oxide to lose the oxygen so that it can gain. Hydrogen is making this cupric oxide to lose oxygen. It means loss of oxygen is called reduction. In other words, we will say that it is the hydrogen which is making cupric oxide to undergo the process of reduction, and that's why hydrogen is known as the reducing agent. It is called reducing agent because it is carrying out or it is making the cupric oxide to lose the oxygen so that cupric oxide can undergo the process of oxidation. It means hydrogen is just bringing about the oxidation of cupric oxide into copper. That why hydrogen is called reducing agent, and the cupric oxide is bringing about the oxidation of hydrogen into water, and that's why cupric oxide is called oxidizing agent. So that's all about the redox reaction. We are left with only one definition of oxidation and reduction which is known as the electronic concept. And as I have told you in the very opening of this very discussion, that is, yes, we are gonna take on that very definition, electronic concept, in the very next video, where we are gonna discuss the another type of chemical reaction called displacement reaction. So that's all about redox reactions. Thank you.